Hello, I will now go over the 10-8 problem set. So the first question, um, r equals -8. This is a circle with radius 8. That's because this is all the points that are -8 away from the origin. But if we have -8 away from the origin, that's also just the points that are +8 away from the origin. So it's just going to be this graph here. Make sense? So if you had, for example, r -8 and theta 0, that would be right here, correct? Then you just, as theta gets bigger, the points would just move in that direction. So it's the same graph as r equals +8. Next one, r equals 4 cosine theta. Now this is going to be a circle touching the origin, remember? Anything that's a sine or a cosine is always going to be a circle touching the origin. And we just need to figure out what direction it's facing. And so we're going to let's plug in a point. We could plug in theta equals 0, and that will tell us that cosine theta is 1, so r is 4. And so that would be this point here. And we know that that has to be the furthest point from the origin, so the circle should look like that. Okay? And this length here is 4. C, we have 4 minus, I'm going to expand it, so 4 minus 4 sine theta. So for this question, a over b equals 1. So that tells us we have a cardioid graph. And for any Limaçon, we have to plug in 4 points. Let's plug in those points. 0, pi over 2, pi, and 3 pi over 2. If we plug in 0, sine 0 is 0, so it's 4. Sine pi over 2 is 1, so that's 0. Sine pi is 0, 4. Sine 3 pi over 2 is -1, so we have 8 here. And then if we graph those points, 4, 0 is right here. 0 pi over 2 is here. 4 pi is here. And 8, 3 pi over 2 is here. And so the cusp is always going to be where it connects to the origin, right? So the cardioid should look like that. And make sure it's round at the bottom. Next, question D is also another cardioid because A equals B. So let's calculate the 4 values of theta. Theta equals 0 means cosine 0 is 1, so r is 12. Cosine pi over 2 is 0. Cosine pi is -1. And cosine 3 pi over 2 is 0. So graphing that, 12 zeros right there. 6 pi over 2 is here. 0 pi is there. And 6, 3 pi over 2 is there. It's not the best. So that's our cardioid graph. E, r equals 5 minus 2 sine theta. Now in this case, a over b equals 5 over 2, which is greater than 2. So that means we have a convex Limaçon, right? Convex Limaçon. So let's plug in some points to get the right locations. Sine 0, 0. Sine pi over 2 is 1. Sine pi is 0. And sine 3 pi over 2 is 7. Sorry, sine 3 pi over 2 is -1. So it gives us R7. So then graphing this, we have 5, 0, 3 pi over 2, 5 pi, and 7, 3 pi over 2. And this is convex, so there should be no dimple at all. It'll just be flat here, and then it'll round out like that. Okay. It's not an oval, it's not an ellipse, because it's not symmetrical. It's convex Limason. F R equals 2 minus 5 cosine theta. Here we have A over B equals 2/5, which is less than 1, so we should have a looped Limason. Looped Limason. Let's plug in the 4 values. Cosine 0 is 1. Cosine pi over 2 is 0. Cosine pi is -1. Cosine 3 pi over 2 is 0. Okay, so where is -3, 0? Well, the angle is this way, but r is negative, right? So actually the point will be right there. Where's 2 pi over 2? That is around here. 7 pi will be here. And then 3 pi over 2 is here. All right, so this is going to be looped, remember? So we're starting here, and then it's going to loop like that. And then the other side of the loop has to pass through the origin. Should be rounder. Okay, something like that. Let's do G. G is another looped Limason. So sine 0 is 0, sine pi over 2 is 1, sine pi is 0, and sine 3 pi over 2 is -1. So 4 comma 0 is right there. 10 pi over 2 is going to be quite high up. 4 pi is here, and the -2, 3 pi over 2 is actually going to be here, right? So the loops will look like this. Okay, it's not very symmetrical, right? Could be better. H. All right, we have some rose curves now. R2 cosine 2 theta. Here n equals 2, which means that we're going to have 4 petals. Because n is even, so we are going to have 2 n petals. Okay, so let's try to figure out where one of the petals are. We just need to find one petal, and then the rest of the 4 are going to be evenly spaced. So to find a petal, we're going to try to make cosine 2 theta equal to 1, because that will give us a maximum. So when does cosine 2 theta equal 1? Well, it equals 1 when theta is 0. So we should plug in theta 0, which should give us r equals 2. So that tells us that we have a petal at theta 0, which also tells us the location of all the other petals. Okay, and the petals also go in that order. Next, let's do I. So we have R equals 3 sine 3 theta. N is equal to 3, so that means we have 3 petals because N is odd. So R theta. Now what should we plug in? So we want sine 3 theta to equal 1, because that will give us a petal when we have a maximum R. Now for sine 3 theta to equal 1, that means 3 theta has to be pi over 2, or something like that, which means that theta equals pi over 6. So that's going to be what we want to plug in. And when theta equals pi over 6, we have sine pi over 2, which is 1, so R equals 3. So that means one petal is going to be at pi over 6. But if they're evenly spaced and we have 3 petals, that means that petals should be separated by 120 degrees, because 360 divided by 3 is 120. And so that means the next petal has to be at 150 degrees. And then the third petal must be at 270. So the petals will be located in that direction. So that's what the rose curve looks like in that case. J, R equals 6 cosine 3 theta. Once again, we have 3 petals. What should we plug in here? We should plug in theta equals 0 to get a petal, because cosine 0 is 1. So that means we know we have a petal at 0, which tells us that we'll have a petal at 120 and also 240. Let's do K now. I did not go over K in class, but you should be able to do it using techniques that you learned from last class. It's just kind of in reverse. Okay, so we have R equals 5 cosecant theta. What do you do here? You just rewrite the right-hand side to be 5 over sine theta, and then multiply both sides by theta. But here you can make the substitution y equals r sine theta, right? And so that tells us that this is just y equals 5. And so to graph this, you just plot the line y equals 5. Okay? So even though I didn't teach you how to do it, you can just convert it back into a rectangular equation, or an equation that has x and y, and that will immediately give you the graph. Same thing for question L, or equals to secant theta. That's just 2 over cosine theta. So that means r cosine theta equals 2, and r cosine is just x. So this is the equation for that, which means that the graph is just a vertical line at x equals 2. Okay, label 2. M is the same exact concept, just looks complicated. You're going to want to multiply both sides by the denominator, which will give you 2r sine theta minus 3r cosine theta equals 6. And r sine theta is y. Sorry. R sine theta is y, so this is 2y, and r cosine is x, so this is 3x. And then you can graph this in different ways. You can find the intercepts immediately from this, or you can write this in point slope form. That's what I prefer doing. So I'll move the x to the right side and get the y isolated. And so that's how I graph it. Okay, so I have slope 3/2 and intercept positive 3. So that would be an acceptable graph. Then the last one is very similar. we have r sine minus 2r cosine equals 3. So that's y minus 2x equals 3, or y equals 2x plus 3. It's a very similar graph, isn't it? Slope 2, intercept 3. So it's going to look like that. Almost the same thing, just steeper. So that's all the solutions. Thanks for watching. Good luck.